Hi, and welcome to the video on classifying polynomials. With this video, you have the option of taking notes in your composition book, or you can use this note page which summarizes what we know about classifying polynomials. As you see that there are 4 boxes here. The first box, you describe what classifying means, and then in the other boxes, you would list the steps and the examples that you would use to classify a polynomial from 3 different representations: the equation, graph, or data table. All right, let's begin. So this is where you would fill in either the first box on that note page there or in your notes. Classifying means to group something based on some property. And in addition to classifying polynomials, there's other things we can classify. Let's take, for example, vehicles. So if you are looking at these 2 vehicles here, we would say this is a sports car and we would say this is a pickup truck. What that's describing is the class or the type of vehicle that we're looking at. And the properties that we use to classify vehicles would be how fast they are, their shape, their size, sort of features that they have. And what that allows us to do when we classify something like vehicles allows us to make predictions. So if you had to move a couch, for example, and you wanted to decide which one of these vehicles would be best for you to use to move a couch, you wouldn't even have to see the vehicle. If someone said it was a pickup truck and versus a sports car, you would know you would want to go for that pickup truck because of the size and the features of that vehicle. So when it comes to polynomials, how do we classify them? Well, just like with vehicles, we give it a name when we classify a polynomial, and there are 2 types of names we can have. We can either have a name based on the degree or based on the number of terms. Now, the steps that we use to classify a polynomial depends on the representation. So what I mean by representation, are you given the graph of that function, the equation of the function, or the data table? All representations can be classified by the degree, but it's only the equation that can be classified by the number of terms. Let's get started with some examples. We're going to focus in this video on the graphs and equations. There's another video for classifying polynomials from the data table. So if you're using that note page, you're going to find the box that says classify formula or from a formula or equation. And this is where you would want to enter the notes, write down the steps, and you can use this example or choose to use another example to list with the steps so you can follow the steps along. So let's say we have this equation here. We know it's equation because it has an equal sign and there are 2 things on either side of the equal sign. So the first step in classifying is we have to set this equation up right, and we want to simplify it by combining like terms. So take a moment in your notes on a scratch piece of paper or wherever, see if you can combine like terms. Press play again when you are ready to see the answer. All right, so you probably noticed that if we're looking at the terms here, we have 2x, which has a like term with which is a like term with negative 5x, and 3x, and if we combine those together, they will cancel out. Negative 7, there are no like terms to combine with it, so that will just say. 3x to the 4th and minus 2x to the 4th, those are like terms, so we can combine those. And x to the 5th, there's nothing to combine it with. So when we do all that combining of like terms, we get this expression here, f of x equals negative 7 plus x to the 4th plus x to the 5th. The next step is to arrange in standard form. Now actually you don't have to do this step in order to classify it. You could still classify it without doing it that way. But the cool thing about arranging in standard form is that, remember with standard form, the term with the highest power goes first, and then all subsequent terms follow after. And when you do that, your eye always knows to go to the first term to find the highest power, which you'll need to classify. Take a moment and arrange this in standard form. And then when you're ready, press play and I will show you the answer. Great, so here we have it in standard form. The highest power here was fifth power, so this term here, x to the fifth, that's going to go first. The next highest power was the fourth power, so that one, the x to the fourth, goes second. And then we have this minus 7. Notice that I brought down with the 7, its sign, minus. We have to be careful of that. So these first two steps are just setting us up so we can actually classify things. The third step is where we're really starting to classify. So we need to find the degree, which is the highest power, and name it. Go ahead and find the highest power. Now that it's in standard form, should be easy to do. All right, so we see that the highest power is 5, and if we're using our chart here, you're going to have to memorize this for the test. We're going to look at the chart, and we're looking under the degree, and we know that our degree is 5, so for the degree name, we're going to call it a fifth degree. The last thing is to count the number of terms and name the polynomial based on the number of terms. And so if we take our expression here, go ahead and count how many terms you see in this in the equation on this side of the equation. Awesome, 3. There's 3. So going back to our chart here, we're going to now look at this chart specifically with the number of terms. There are 3 terms, so we would say it's a trinomial. And now we can give it the full name, the first and last name. So this would be called a fifth degree trinomial. Find some other examples for extra practice in your packets from your notes. Let's go on to classifying a graph. So the process for classifying a graph is a little different. The first step is to count the number of vertices or turning points. So go ahead and take a moment, see if you can count the number of vertices or turning points. Great, you probably noticed that there are 3 vertices. Remember, vertices are where the graph changes the direction. So there are 3 areas where that happens. The second step is to add 1 to the number of vertices to get the degree. So we have 3 vertices here. Go ahead and calculate the degree following this step. Right, the degree is going to equal 3, which is the number of vertices, plus 1. So that's going to give us 4. This is the fourth degree polynomial. And now the last step is to name, and again, we can only name by the degree only, because we cannot tell the number of terms. So let's go ahead and look at our chart here. Where should my eye go? Should I look at this section or at this section? Of course, the degree section, because that's what we have. That's the information we have. And go ahead and find the name based on the degree. Great, it's quartic. So we would just say this is a quartic polynomial. Remember, you have to know those names, those special names, for the test. Let's do a couple of quick CFUs to see what you remember. The first one question is, when can you classify a polynomial by both the degree and number of terms? Right, when you have a formula or equation. If you have a graph or data table or even equation, you can classify all of these by the degree, but it's only the equation that will tell you the number of terms. Second one, when do you need to add 1 to find the degree? Great, you're only going to add 1 when you are classifying for a graph. You add 1 to the number of vertices. I hope you found this video helpful and have a quality day.